Hello. Let's see. Yes, everything works. Today I am going to show one way to completely trivialize any multiplication equation. Doesn't matter how big it is, you will always be able to figure it out. I have used this method I came up with yesterday a bunch of times, and it went to differing amounts of success. Sometimes I made a mistake, sometimes I didn't, but I'm still getting adjusted to it, so bear with me. To explain how I found this, there was first an observation I made back in elementary school. The observation was quite simple, as you would think. It's like, well, 5 times 5, that's 25, but 6 times 4 is 24. 7 times 7 is 49. 6 times 8 is 48. 100 times 100 is 10,000. But 99 times 101 is 9,999. Always one difference. Long while later, thinking back upon it, I was like, well, what if you have... Well, instead of saying it's one difference, and I will ask you to bear with me, let's say it's 1 times 1 difference. Okay? You will understand why soon enough. So then I was like, okay, what's 6 times 5 and 4 times 7? Well, that's 28. That's 2. Well, the reason why I call it 1 times 1 is because, well, let's use some space here. 7 times 7 equals 49, but 5 times 9 equals 45. Thus there is a 2 times 2 difference. And that's why I call it 1 times 1 difference. Then this is a 1 times 1 plus 1 difference. And if you do 3 times 8, then compare it to the original 6 times 5, you will also notice a 2 times 2 plus 2 difference. Also funny is that these two only have a 2 times 2 difference. I actually never noticed this before. Here plus 2. See? Okay. The method I'm going to show was after I went one step further, and that was yesterday. And I was like, what if 7 times 5 and 8 times 4? Okay, well, no, 32. 35. 1 times 1 plus 1 plus 1. Or 1 times 1 plus 1 times 2. And why is it 1 times 2? What's 7 minus 5? There you go. Let's start with a simple example. Two numbers on both sides, rather long. 23 times 18. Okay, we turn that into 21 times 20. Just 1 is 10. Then, well, the difference is 2, so 2 times 2. And the difference between 21 and 20, plus 1 times 2. Well, there is a thing, and that is if plus or minus. Now, I'm gonna say something very confusing. If it's a plus sign, you will have to subtract it from the total value. If it's a minus sign, you will have to add. And you have to subtract because 21 times 20 is greater than 23 times 18. That is because the numbers are closer together. These two, 21 and 20, are closer together than 3. So you will need to take 410 and subtract 6 from it. 404. Hilarious number. 23 times 18. Boom, 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 boom. 414. I am a dumbass. This is 420. Yeah, okay. It fucks up, but okay. See? Let's do another one to clean away this disgusting feeling. This time a bit bigger. So 45 times 36. And we just turn that into 41 times 40. And this time, don't forget, it's bigger. So, okay, we have 1604. Okay. This one is greater. And no, I'm not saying that this is greater than 1640. Yeah. And now we take 4 times 4. And then we add 1 times 4 for a nice 20. And we say 1640 minus 20 equals 1620. Right? Seems to be good so far, but who knows, I might fuck up. I'm still getting used to this. I don't blame myself anymore. Okay, simple, 1620. Then you might say, okay, you can do it for 2 times 2. That is not the only number I have done. I said before that I've done it before and I fuck up, but I have done big numbers before. Then I'm talking like this, something similar to this I did. But let's go one step up. 265 times 360. Now that is not jumbled enough. Let's do it like this. Okay. Let's do 500. So that means this one is bigger. Times 788. So what you need to do now, when the upper number is bigger compared to the lower number, is you take the difference, which is 288 times 12, and then you subtract 12 times 12 from it. So you're left with 276 times 12. Now this seems pretty small enough to still calculate, like you just do this plus, okay, that times 2 is 552, I guess. Then you just add those together and you have 3312. Okay. And you say, okay, what's this? 788, you just divide that by 2. So that is, okay, so the last number is 4. Okay, so 350 plus 40 plus 4, so 394. Oh, right? Okay, this is correct because you need to do 5 times, so that's 394. Okay. And then you add 3312 to it. So you will be able to say 397 312. Okay. Let's see if I'm correct. 512 times 776. Hey, what you looking at? Quite easy, isn't it? Okay, but let's get on to the more fun stuff. I will also show you numbers that I won't be able to do, but let's go to what I can conceivably still do. I just have a very tough time with it. 16 for 24 times 5,571. Okay. Big numbers. Like if you ask this to someone and you give them a pen and paper, they might take hours. I did it in about 8 minutes. Okay. Well, I am more comfortable with subtracting rather than adding, I would say. You can make it a full subtraction sum, or you can add and subtract in different steps. I think I will keep it simple. So I want this rounded up to 6,000. Well, how much do you need for 6,000? 429. Okay. 1 5. Can I do 16,000? Is that alright? Mm. Which one do I prefer? I think I will go for 5,000 anyways. I might just have to adapt a bit. But this seems like so much easier to calculate. So I will just go for it. Okay, well you just do that. You have it, so you have 8. 900 is 450. 49. I think this is correct. Um, so let's just do as if I want 10,000 and see if that still holds up. So we have here the 8 number, and I have to ask is it the half of it? I think so. Might be wrong, might be. But you can literally change it to anything, so if you have the patience, you can just go for anything. Okay, which one is bigger? Up above. So you need to add something. Okay, what do you need to add? Okay, well there you go. Little one, 985 times 571 minus 571 times 571. Now I would like to. I would have liked to, be able to do this, but for now, I got it. So 1142 times this and one. And look at that. It's literally this minus this. If you can remember that, then you can just apply it constantly whenever you do this. The minus. Okay. Is that any solvable or do I need to change it? Well, let's change it up to 1,000. Or I can say 11 times. No, let's just go with 1995 times 1,000. Okay, that's 109,500. 9995 times 571 minus. Nope. Because this one is bigger. So it's plus 571 times 571. Well, can I do this? I mean, if I do that, that saves quite a lot of time. So let's just 571 minus 571 times 5 equals 571 minus. Okay, that's 5, that's 350, and that's 2,500, so that's 2855 equals 570715. Okay. I just need to find out this part. 571 times 571. No fucking clue. But I can just keep using the method. Nothing is stopping me. Literally nothing. So 600 times. So 571 minus 29 is 542. This is a bit less comfortable than I like, but I could just switch it one number. Sure. It's all about what type of priorities you have. If you can calculate 29 times 29 by head, which actually I can, well, not exactly, but I suppose I will make do with it. So, okay, equals 10542 times 6 equals, well, okay, you have 24,000, you have 300,000, so 32, 24,000, okay, 5, 2, oh, okay. What remains? So I have 29 times 29. This equals 30 times 30 minus 30 minus 29. I haven't explained it, but it works. So, whatever. Deal with it. Yeah, you just have to kind of imagine in your head, like you would take 130 and lower it down to 29, and then you would have 29 times 30, and then you take the other 30 times and you minus it by 29 because it's 29 times 30 and not 30 times 30. That's how it works. Okay, so that's 900 minus 59 equals 841. Okay. Then you have the other part, of course. And it has to be said that this one is bigger. Right? Now this one is bigger, so minus it. So what do you subtract 841 of? Okay. 58 times 29. Beautiful. You just 58. You just do that minus 841 and you have 841 left. Beautiful, isn't that? So, you just add 841. What happens? 326 041. Okay. Let's note that down. You need to add that upon this, I would assume. Right? Here? I think it's a minus because the lower sum is higher. Sorry, it seems I am confusing myself with something I did. No matter, of course. Yeah, we have this. Now, this we need to add 571 or subtract. We needed to add and then subtract it off of that number. So we just do plus 326,041 equals 6033,186. And then we do minus that equals 49. Six, one, 814. Which is this, by the way. And now just do plus 4961814 equals 8915. No, my bad. 5, 8. Am I missing something here? So 84 plus 4 million equals 88 million. Oh, it's not a 5, it's a 0. But it's a 1. Because this and the 7 will stick together, giving it a 3. A 6, 8, 1. Then we say This equation equals this number. I have no idea if that's correct. Not a clue. I could have made a mistake somewhere, and if so, I apologize. 16424 times 5571. Moment of truth. Is that the correct number? Fuck no, it isn't, but at least it's somewhat similar. I was off by 2 million. Why is that? Well, I think that this equation I did something wrong here. I mean, why is this number so small? Why is 600 times 450? I'm not sure. But hey, let's move on. Because even if you can't do everything correct, even if you make mistakes, you can still make some great estimations. For the final trick, this. Just not normal. Complete nonsense. Let's start with this. 200,000 times, well, what happens if you add them together? Okay, let's just. I want to be absolutely certain that I'm correct. So let's take it a bit slow before I make something really stupid. Okay. We just double the numbers. We get 2, 6, 4, 16, so that's 5, 6, 8, 0, 2, 0, 0, 0, 0, 0, 0. Wow. And then we can do a whole new sum. But first we need to determine which one is bigger. This one is bigger. Cool. Great. Okay. This might be its own group. So let's leave it alone. Next group. Okay. 198,567 times 198,567. And then the difference between those numbers is 671,599 times 198,567. This is a minus, so I need to add this at the end. Well, I will just write from the back because that is kind of just easier. So, okay, great. And then we do, well, most logical is just to kind of turn it into 200,000. So we do 200,000. Okay. Times, well, what happens if you add 1500 something? Oh, sorry, I subtract 1533. 1533. Oh. Okay. Double the numbers. See, I love numbers like these. And what do you have as a remnant? We need to also make sure that I know that this one is bigger. Did I just make one big mistake? I will need to subtract something off of this. Not bad. When you have stuff like this, you will be very prone to making mistakes. It's of course a bit late, but no. Quite a damn shame, isn't it? Let's just add 200,000. And then that minus 1433 equals. Hey, look at that. Great. Now I need to do minus 1433. See, I'm being quite dumb about this, but still, it's full. Okay, no. It isn't, but it makes good estimations, even if you're being a dumbass about it. So, hey. Well, this one is quite big. Boom. There you go. So I will need to add them together. Well, we know what is 1433 times 1433, and then you can just add the other, which is, okay, 668,733 times 1433 equals, well, okay, that's just 6, 7, 0166 times 1433, which I can just drop down here for, formatting. And where can you change this to? You can go up, you can go down. Let's keep on with the 2000. Just keep reducing more numbers. Okay. Okay, we do times 2000. Doesn't matter which side you do, I just like to do this because it's easier to know what you're going for that way. Six, nine. No. 6, 6. 9. Need to do plus 5, 6, 7. So 5, 6, 7 off of it. Is that 999? No, it isn't. 5, 6, 7. Keep paying attention. 11 minus 5 equals 6, so I need to put 5. Then 67, then you have 99. This is perfectly calculable. Too bad it's not the end step. I would have loved that. But 1, 3. 3. 9. 1. 9. 8. 0, 0, 0. What's the remaining sum? Oh. 5, 6, 7, and 5, 6, 7. This one is greater, so it's all addition. It's all addition. All of this is addition. Then you will have subtraction at the end. A lot of subtraction. Plus. Six, 6, 7, 5, 9, 9 times 5, 6, 7. These numbers are getting ungodly. But okay. Resuming. 6, 6, 8. 1. 6, 6. Seems like it. Times 5, 6, 7. You press the space bar. Is this a sum you can calculate by hand? If so, then you're the best. Well, I don't really care about the 2000 pattern anymore, so I guess I'll just round it up to 600. So 6616, 33, so 33 times 600 equals, okay, first we start with 36, then we add another 6. Okay, let's just do this bit by bit. So we have 360,000 plus 36,000 plus 4,800 plus 600 plus 198. So we just add these ones up. 798, and then this can be 40,800, and then this can become 400,800, and then we just add this together for a nice 159. Right? The answer is sure, let's go with that. Okay. What remains? Well, this is still here. If you keep it consistent, then that means you will never have to do anything else. Either it's all plusing each other or all minusing each other. Go for whichever you prefer. Multiplying something by 33 is not my favorite thing, but maybe it's possible. Plus 33 by 7. Nice as possible, the answer is sure. So let's do it. Let's just calculate this. So we just do 1/8. Then you have 1/8 again, so that's 9/8. No, pain in the ass again. Okay. 600,000 plus 60,000. Let's start with 198. 0, 0, 0. 0, 0. And let's do the rest. No, actually, let's just multiply it by 3 for now. Plus 21,000 plus 1,500 plus 198. Okay. We can just do 2,001,000. Add a nice 1,500, so that's 25. Then add 198 for 698. And that's this times 3. And then you just add that together with. And then you just go from the back with 8, 7, 6, 9, 2, 0, 2, 2. Okay. We all good? Seems like it. Okay. This is the critical moment. So let's just delete this garbage and use our final sums. Because this is going to be subtracted from that. Excuse me, did I miss a 0? Well, let's just redo it, just to be sure. What is 600,000 times 600? Okay, you have 3 6. And you have the 5 zeros. You have 2 zeros. How many digits does that have? 9. How many digits does this have? 8. See, you can easily fuck that up if you're not careful. And you just say, okay, that minus 2, 2, 0, 2, 9, 6, 7, 8. And what do you get? Okay, you got 3, 7, 9, 3, 0, no. Okay, 6, 8, 3, 2. 10 numbers, 10 numbers. See? That means I missed a 0. Again, if you don't count your zeros correct, you will also fuck up. It's happened many times to me before. Whatever. We just keep going like nothing matters. Then we say, what the fuck is this? Okay? Well, start out with 9. Then we have a 5. A 9. A 6. 6, 1, 6, 7, 8. Okay. I will also keep doing this so that if anything is wrong, you can just directly correlate whichever you have. If you did this wrong, or if I did this wrong, well then, too bad. How many numbers does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 versus 9. Okay, makes sense. But let's just check. Okay, cool. That means that I didn't fuck up. You can always do that little check. Okay, so what's happening? I get confused sometimes. My apologies. I convert over this, so that's 8, 7, then we do 4 and 5, turning it into 9, but actually 8. Then we say 6 and 9. Which here showing would be 7, but it's 6. Then that's 9. Three, 8, 3, 2, 2. And then the final sum, ladies and gentlemen. But first, this has 13 numbers. Seems to be correct, right? Yep, same size, all correct. Equals, this is a 12th number. So, we get a free 2. We say 4, 8, 4, 0, 1, 5, 0, 6, 1, 6, 7, 8. And this is the end result of our insane journey. Let's just copy and paste it down below and see how far off I am with this personal method. 2, 1, 9, 8, 5, 6, 7 times 1, 1, 2, 9, 8, 3, 4. Moment of truth. 2, 4, 8, 4, 0, 1, 5. I was off by a few 100,000. A few 100,000. That is what happens when you get really good at this. You'll be off by only very small margins, if you're off at all. Like you could genuinely do this in like one go. You can do anything with this method. As long as you know which steps to take, what to plus and what to minus. Like, I'm fairly sure that what I did was just one of the counting mistakes over here. Like, I just made a counting mistake and that made my 100,000. But this is how strong the method is. If you're smarter than me, which is highly likely, you could do a lot more with this than you might expect. Well, anyways, that was my video showcasing the way how to make multiplication trivial. Thank you for watching. Please leave a like, subscribe or don't, I don't care. Just like the video, leave a nice comment. See you.